Beyond the one-model mindset, why machine learning needs diversity. One key difference between classical statistics and modern data science machine learning, DSML, lies in how they approach analysis and decision-making. Classical methods often focus on drawing conclusions from a single analytical approach, while DSML emphasize exploring problems through multiple models and perspectives. That said, many practitioners trained in the classical school still bring that one-model mindset into the world of machine learning, sometimes to their own detriment. A study by computer scientists at UC San Diego and UW-Madison directly challenged this traditional reliance on a single ML model, especially when the stakes are high. Their research asked a fundamental question: what happens when models with similar overall accuracy produce different outcomes on specific inputs? The results were revealing. Stakeholders became uneasy when different models produced different outcomes, even when all models were technically valid. People instinctively questioned which model to trust. Based on these findings, the researchers argued for a paradigm shift. Rather than depending on a single best model, we should embrace multiple models and bring in human judgment when conflicts arise, especially in high-impact scenarios. This idea isn't just theoretical, it's actively shaping the future of AI. Take Elon Musk's XAI as an example. One of its models, SuperGrok Heavy, uses a multi-agent setup where different agents generate responses independently. Then, a separate review agent compares, selects, or even synthesizes the best output. This approach doesn't just generate deeper answers, it intentionally avoids over-relying on any one model, producing results that are more robust, thoughtful, and accurate. Compare that to something like ChatGPT, which sometimes provides multiple perspectives or refinements, but typically leaves the final evaluation up to you. SuperGrok Heavy goes one step further. It brings in a higher-order reasoning process that automatically weighs competing answers and selects the most compelling one. That's not just convenient, it's a leap toward meta-reasoning, reasoning about reasoning. It's the difference between saying, here are a few answers, and here's the best answer, and here's why. This architecture reflects well-known strategies in data science. Practitioners often test out multiple models, say, support vector machines, generalized regression models, XGBoost, and random forests, then compare them using various metrics to decide which one performs best. These techniques fall under the umbrella of ensemble learning. Grok's setup also echoes a concept from philosophy of science called inference to the best explanation. When several plausible hypotheses exist, you favor the one that best explains the available data under reasonable assumptions. By embodying this reasoning process, modern AI systems are moving beyond simple output generators. They're starting to evaluate the quality of their own thinking, automating both abductive reasoning and model selection heuristics. That's not just an incremental upgrade, it represents a fundamental shift. We're transitioning from reactive pattern matchers to self-aware cognitive agents. That's not just more powerful, it's a whole new category of intelligence. And this isn't just philosophy, it has real-world implications. Imagine two medical AI systems that both achieve 90% accuracy on paper, yet recommend different treatments for the same patient. That inconsistency is not just theoretical, it's a genuine ethical and operational challenge. Model disagreement in high-stakes domains like healthcare, finance, or criminal justice requires careful orchestration of models and, more importantly, judgment. But here's the catch: diversity is essential for this kind of ensemble modeling to work well. If you're just sampling multiple outputs from the same language model, it's kind of like asking several professors from the same department at the same university. Sure, you might get different answers, but they'll likely be influenced by similar academic norms and biases. To get truly distinct perspectives, you'd want to ask a psychology professor at UCLA, a philosophy scholar at Stanford, and a computer scientist at MIT. The same logic applies to AI models. Platforms like EdenAI and LLMarina.ai let you query multiple large language models, ChatGPT, Gemini, Claude, and others, and compare their outputs side by side. That way, you're not locked into the worldview of a single model, but rather engaging in a multifaceted dialogue across AI systems. Also worth noting, diversity doesn't mean noise. The goal isn't to create chaos or contradiction, it's to surface intelligent variation that reflects meaningful trade-offs and reasoning paths. Just like a well-rounded research team, different models can spot things others miss. In fact, even OpenAI has explored variations on this theme. Techniques like chain-of-thought prompting with self-consistency generate multiple reasoning paths and then pick the most consistent result. Internal multi-agent discussions or critic-helper frameworks also reflect this trend toward automated internal deliberation, a powerful form of collective intelligence within a single system. In short, the future of AI isn't about building the perfect model, it's about building many good models that can reason, disagree, and reconcile like thoughtful collaborators. So, what do you think? Are we ready to stop leaning on single model answers and start embracing real plurality in machine learning? If this sparked some thoughts, drop a comment. And if you found it helpful, feel free to share it with your friends and colleagues. Thank you for watching. Mahalo.